Hi, my name is Monica Escobar and my partner Violet Salas. So today we got topic transition group metals and physical and chemical properties of those elements and why do they form variable charges while most of the main group metals have the fixed charge, and how to write or name an ionic compound that contains transition metal citation. Let's get started. So I'm going to be talking about the first two questions. So what are transition group metals? Transition metals are all the elements in group 3 to 12 of their periodic table. The transition metals are properties such as a superior ability to conduct electricity and heat. So this is the discovery of the transition metals. Iron is a far the greatest prevalent of transition metals inside the atmosphere solid code, ranking the fourth between all chemicals and second of crustal occurrence. According to Bryanica states, the elements of titanium, magnesium, zirconium, vanadium, and chromium also have an abundance of excess of 100 grams, 3.5 ounces per ton, which are useful for the transition metals. There's also 4 principal transition metals acknowledged to the ancient world, which were the copper, silver, gold, and iron, the most common use in humankind. In Latin, it was translated as corporium, arcanium, aurum, and ferrium. I think I butchered it right, but I tried. The chemical symbol were written as CuHe, Au, and Fe, and it was discovered in early 18th century. What are the physical properties? Some of the common physical properties are the transition of metals allow the charge to move easily through the heat and electricity. The transition metals can be shaped easily, bending, or hammered. And then the metals do have high melting points, and they also have high density, and they're usually strong and hard physically. And then for the chemical properties, some common ones are silver and gold are not reactive. Most metals are used as catalysts and they also form color ions of different charges, and transition metals are not as reactive than the alkali metals such as sodium. And then the use of it, so gold and silver, for example, in physical properties, they can be used as jewelry because they don't really react with gas or water in the room. Because it does not react in room temperature. It can be also reshaped, and gold can be also used as electricity. And then copper can be used in electrical wire because it can be shaped into wires and it has good conductor of electricity. And also be used as water pipes because it's not reactive in water and it could be reshaped as well. And to continue, iron is generally too mild to be utilized as a single metal, so it could be mixed with other elements to produce steel. And also bold and stronger than iron, that it can be easily reshaped, and it can also be used in building, bridges, shapes, and cars. Increases the pace of the some reaction. However, it can be regained of their original form at the end, like the chemical industry. And then chromium is also used to coat on metals like bicycles or cars, anything like that. And when polished, it retains its luster and is highly durable. Same as iron, the chemical industry increases the rate of certain reaction, but it can be recovered and unchanged in the process. And then chemical properties of the transition metals. So reaction with oxygen. In a moderate temperature, and group 1 metals interact rapidly in oxygen in the atmosphere at room temperature. Most metals elements react slowly, if at all, with oxygen. When heated, several transition metals react with oxygen. So here's an example. Copper plus oxygen, it equals to copper oxide. So this is an oxidation process in which copper contributes electrons to oxygen and generates copper oxide, indicating that metal has been oxidized. And here's the example, the picture at the bottom. And so reaction with water, cold water does have a strong reaction in group 1 element, but most transition components respond slowly, just as hardly with cold water At room temperature, iron reacts with water and oxygen generates a hydrogen ion oxide, also known as rust. And here's an example of the picture at the corner, as you can see. And then reaction of halogens. So transition metals react to halogens as well. Iron plus chlorine and then equals iron chloride. So it's used as clean sewage, industrial waste, purify water as imprinting agent for engraves. Oh yeah, it's just basically purify water and like any other production of the chemicals. And then catalytic activity. Catalytics are chemicals that boost the pace of a process despite being consumed by it. And then the Harper process produces ammonia by reacting nitrogen and hydrogen. And magnesium oxide accelerates the breakdown of hydrogen peroxide to HCl of water, of course. And then color compounds. Here's an example like how these compounds can transfer into color. So I put one example. So as the first one, iron hydrogen oxide. So as you can see, it's like a pale green color. As for the rest of them, it could be transferred into like orange brown or red brown, anything like that.
What is variable charge in the transition metals? The charge on the transitional metal atoms is equal to its oxidation state and can vary from +1 to +7. Transitional metals can lose electrons more readily than other elements because they have unstable electrons in their outer orbitals. Why do they form variable charges while most of the main group metals have a fixed charge? The reason is that there is not a considerable energy gap between the 3d orbital and 4s orbital. The 4s electrons are lost first. In transition metals, the ionization energy required to remove the third electron on the 3d subshell is not much bigger than the ionization energies required to remove the first two on the 4s subshell. The small difference between the ionization energies make it easy for transitional metals, like vanadium, to have variable oxidation states. Not much energy is required to remove a small number of electrons from transition metal. Transition metals of the first transition series can form compounds with varying oxidation states. We have in 21 scandium, 22 titanium, 23 vanadium, 24 chromium, 25 manganese, 26 iron, 27 cobalt, 28 nickel, 29 copper, and 30 zinc. Naming ionic compound with transitional metals. Transitional metals naming are more challenging. The key is determine the ionic charge on the metal and use Roman numerals to indicate the charge on the transitional metal. Naming ionic compound with transitional metals step by step. Write the name of the transitional metal as shown on the periodic table. Write the name and charge of the nonmetal. If you have the polyatomic ion, use the common ion table to find and write the formula and charge. Use the total charge on the nonmetal or polyatomic ion. Find the charge on the transition metal. After the name for the metal, write its charge as a Roman numeral in parentheses. Note: that there are no spaces between the letters and the parentheses. Examples of naming ionic compound with transitional metals. FeCl2 is iron 2 chloride. Fe2 positive is iron 2. Fe3 positive is iron 3. Cu positive is copper 1. Cu2 positive is copper 2. In topic 4, we talk about transition group metals in period 4. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. And mention about physical and chemical properties of those elements. Why do they form variable charges while most of the main group metals have a fixed charge? How to name an ionic compound that contains transition metals. Thank you.